Hey everyone, welcome back. So in machine learning, there are some concepts you just have to know, especially if you've got an exam on the horizon. Today, we are tackling one of the big ones, the difference between parameters and hyperparameters. Let's jump right in. To really get this, you have to ask one core question. What is the model figuring out all by itself versus how are we telling it to figure things out? The answer to that question is everything. And by the end of this, I promise you won't just see the difference. You'll get why it's so important. Okay, so first things first, let's set the scene. Everything we're talking about today happens during one specific phase, model training. This is where all the magic happens, where a model goes from knowing nothing to being a smart, predictive tool. The whole point of training is pretty simple, right? You take a model, you show it a ton of data, and you ask it to find the patterns hidden inside. The dream goal is that it gets so good at finding those patterns that it can make really accurate predictions on totally new data it's never seen before. And it's right here in this learning process that our two key players, parameters and hyperparameters, do their jobs. So let's start by popping the hood and looking at what's going on inside the model. We're talking about the stuff the model learns automatically, all on its own. These are the parameters. Right, so here's the key thing to remember. Parameters are the internal knobs and dials that the model is constantly tweaking itself as it trains. Its whole goal is to adjust them just right to get better and better at making predictions. You don't set these, they are learned straight from the data. And when you hear people talk about parameters, you're almost always going to hear about two main types, weights and biases. These are really the fundamental building blocks of what a model learns, so let's break down what they actually do. This slide lays it out perfectly. Think of weights as dials for importance. So if you're predicting a car's price, the weights decide how much things like mileage, age, or color actually matter. A really high weight means that feature is super important for the final price. And biases, well, they're like a baseline, a starting point. Imagine predicting house places. Even a house with 0 bedrooms has some value, right? The land itself is worth something. A bias is like that base value, shifting the model's predictions into a more realistic range. Okay, so that's the inside story. Parameters are what the model learns internally. But what about the stuff happening outside the model? That's where hyperparameters come in. These are the controls that you, the person training the model, get to set before you even hit the start button. Basically, you can think of hyperparameters as the rules of the road for the training process itself. They don't come from the data. They're the settings you choose to guide how the model is going to learn from that data in the first place. Now, you'll see a bunch of different hyperparameters out there, but there are a few heavy hitters you'll run into again and again. We're going to focus on 3 of the most common ones: the learning rate, the batch size, and the number of epochs. Trust me, getting these right can make or break your model's performance. So how do we actually set these controls? Well, it's not about picking a random number and hoping for the best. It's all about understanding the trade-offs and finding that sweet spot for your particular model. Let's start with the learning rate. This one is a big deal. It basically controls the size of the steps the model takes when it's updating its internal parameters, those weights and biases we talked about. This slide nails the trade-off. A high learning rate is like taking giant leaps towards your goal. Sure, you'll get there fast, but you're probably going to overshoot the target completely. On the other hand, a low learning rate is like taking tiny, careful steps. It's way more precise, and you're much less likely to miss the mark, but man, it's going to take a lot longer to get there. Next up, batch size. The idea here is that a model doesn't look at all your data at once. It looks at it in chunks or batches. The batch size is just how big those chunks are before the model pauses to update what it's learned. So a large batch size is kind of like cramming for an exam. You review a huge amount of material all at once. It's fast, for sure, but you might miss the subtle details. A small batch size is the opposite. It's like breaking your studying into focused 20-minute sessions. It takes longer, yeah, but each learning update is much more fine-tuned. And our third key control is epochs. This one sounds a little technical, but it's actually super simple. One epoch just means the model has gone through the entire training dataset one full time. That's it. It's how many times the model gets to study all the material. And this is a real balancing act. If you have too few epochs, the model is underfit. It's like it didn't study enough, so it fails the test because it never learns the patterns. But if you have too many epochs, you get the opposite problem, overfitting. This is when the model basically just memorizes the training data. It's like photocopier Phil. He can ace the practice test, but give him a new question and he's totally lost. Okay, so you've got all these different knobs to turn, and each one has its own trade-offs. How on earth do you find the perfect combination? Well, there's a whole process for this, and it's called hyperparameter tuning. It sounds complex, but the idea is actually pretty simple. First, you just decide on a range of possible values you want to try for each setting. Then, you let your system test a bunch of different combinations from those ranges. And finally, you just look at the results and pick the combination that gave you the best performing model. And there are a few ways to get this done. Grid search is the exhaustive one. It tries every single possible combination, which can be really slow. Random search is often a bit quicker because it just tries a random sample of combinations. And then you have automatic tuning services, which are kind of like the easy button for handling this whole process. All right, let's bring it all home. This last section is your ultimate takeaway. If you're studying for an exam, this is the part you really want to lock into your brain. This is the slide to screenshot. On the left, we've got parameters. What are they? They're variables learned by the model from the data. Who sets them? The model does, automatically. Think weights and biases. Now on the right, we've got hyperparameters. What are they? They're the settings you use to configure the learning process. Who sets them? You do, manually, before training begins. Think learning rate, batch size, and epochs. Look, if you remember nothing else from this entire explainer, remember this one sentence. Parameters are what the model learns. Hyperparameters are how you tell the model to learn. That's it. That's the whole game right there. And that's a wrap on parameters versus hyperparameters. So I'll leave you with a final thought to chew on. Now that you understand these different controls, which one do you think has the biggest impact on that constant battle between training time and model accuracy? It's one of the key questions every data scientist has to answer. Thanks for joining me today.